Hi, Algebra 2. We are jumping in today at lesson 35. So we're talking about angles in polygons. Now we know that every triangle has 180 degrees. We go over that all the time, especially in your online assessments. So your book is showing you there how you can figure out all angles of any polygon, and there's a formula for that. So the formula is just n minus 2 times 180. So we know that every triangle has 3 sides. So n simply means the number of sides. So if I have a triangle that's 3-sided, 3 minus 2 is 1. 1 times 180 is 180 degrees. So that formula holds up for a triangle. Now let's try the formula on a quadrilateral. Every quadrilateral has 4 sides. Well, 4 minus 2 is 2. 2 times 180 is 360. And we know that's true because a square has 4 90-degree, 4 right angles. So 90 times 4 is 360 degrees. So one way that this formula comes about is just thinking, if I have a quadrilateral, there are 2 triangles in it, and every triangle is 180 degrees. So total, that would be 360. So your book shows you pictures there. Say you had an octagon. Well, that's 8 sides. You would just do 8 minus 2 times 180. So that's how I find it. Now, it says find the sum of the measures of an exterior angle for any polygon is 360. So the exterior angles of any polygon is always going to be 360. Interior, this is how I solve it, but exterior will always be. So that is on page 159, and it is in boldface. The sum of the measures of the exterior angles of any polygon is 360. So that's very important. Now, your book shows you inscribed quadrilaterals, and that's showing you how many degrees are in 3 of them or 4 of them, and then thinking through what you know about inscribed angles and how you can solve those. So if you look at example 35.2 on page 160, it has 2 angles, but I have to figure out the other 2. Well, I know that all quadrilaterals have 360 degrees. How do I figure out the others? Well, if I know, and your book shows you that you've got 80 degrees and 75, well, I know that if it's showed me a picture there, maybe I should come to you, because by the time I draw that, it may take a little bit of time. So let me just show you. So we're looking at this example that our book has given us. So if you'll look with me on page 160, well, if you think about that, the 80 degrees is inscribed. So 50 plus Z, the outside arc, that is inscribed, and it's opposite of 80. So I know that 80 times 2 would be 160. So I just take 160 minus 50, and that gives me 110. Therefore, Z has to be 110. Well, if Z is 110, then that directly impacts some of the other sides that we can figure out. Well, I can continue going. And so the book says, since the opposite of a quadrilateral sum is 180 degrees, we can solve for X and Y. So X has to be 100. Well, how come? Because 80 plus X equals 180. And then 75 plus Y has to be 180. So it has to be 105 since they're quadrilaterals. So that's really important for us to know since they're inscribed. All right. So, and that's at the top of page 160 in bold. If a quadrilateral is inscribed in the circle, the sum of the measures of any pair of opposite angles is 180. So really important. Now, 35 is jumping into Algebra 2. And it says there are 2 ways to write the square root of 2. So we already know square root of 2, how to write it with a radical symbol. But did you also know that if you write it as a fraction, so 2 raised to the 1/2, the numerator would be the power it's being raised to. The denominator is the root it's being rooted to. So let's look at some of their examples. So they said, first of all, they showed you different things. So if I say 2 to the 1/3, that equals 2 cube rooted. Or 2 to the 1/4 is 2 to the 4th root. So that's very important to understand the numerator and denominator, how those work. Now, on page 161, it explains that the rules of exponents are the same even with fractions. So if I have x raised to the 5/3 times x raised to the 8/3, it's x to the 13/3. Well, how come? Well, because my bases are the same. I'm multiplying. Exponents are one step behind, so I add the exponents. 5/3 plus 8/3, my denominator stays the same, 3. So 8 plus 5 is 13. Now, it's really important that you follow those rules. Now, look, if I have x to the 5/3 raised to the 8/3, if I have a power and I'm raising it to the power, the step before, instead of raising to the power, step before is I multiply. So I'm just taking 5/3 times 8/3. So my final answer would be 40 over 9. All right. So now it says simplify 4 to the negative 1/2. Well, I know the negative doesn't mean the value is negative. It's its position that needs to change. So it needs to flip to the denominator. So it would be 1 over 4 raised to the 1/2. Well, it's just rewriting the square root of 4. Well, we know the square root of 4 is 2, so you can just rewrite it to the 1/2. Now, your calculators are super smart, and you can actually plug that in, and it will tell you. Now, example 35.4 says simplify. Negative 27 raised to the negative 1/3. Well, the negative 1/3 just means everything moves down to the denominator. Now, one thing I want to point out to you is there is no parentheses. So that negative is going to follow through. And notice your book, I love how it actually gives you pictures of the fingers to cover up the negatives, because the power is only what it's touching. So even with the root there, the negative would be on the outside since it's not touching it. So it shows you that, and it shows you that because the base is 3, it's 27 cube rooted, right? But then the negative is on the outside. Now, example 35.5 is 16 to the 3/2. So it means 16 cubed, and then the whole thing is square rooted. So you can solve it that way. Calculators, I remember when I was in high school, we didn't do it raised to a fraction, but now you can actually plug it in as a fraction and get your answer. So that's super amazing. So try it at home, plug it in, and see how amazing it is to work with. All right, let's look on page 162. It says, find the sum of the interior angles in a 14-gon. So all I'm doing is using my formula, n minus 2 times 180. So the interior angles, I just say 14 minus 2 is 12. So then on my calculator, it's just 12 times 180. Now it says find the sum of the exterior angles. Well, what did our book say? All polygons, exterior angles equals, I can't hear you. I hope you said it at home. 360 degrees, right? Now simplify 64 to the negative 1/2. Well, that simply means, let's take a look at letter C up on my board. So letter C is 64 to the negative 1/2. Well, let's take care of the negative first. It just means 1 over 64 to the 1/2. Now, that's the same thing as saying 1 over the square root of 64, which equals 1 over 8. Very good. 8 times 8 is 64. Very good. Now, letter D says 64 raised to the 2/3. Well, friends, all that means is 64 squared, and then you're going to cube root that. But you can actually plug this in on your calculator. in the fraction format as well. Your calculators are smart enough to do that. All right, be careful on letter E. The negative out front still stands, so you're covering that up with your finger because it's still, when you plug it in, it would be -1 over 125 raised to the 2/3, right? So that means you're squaring 125, but then you're cube rooting whatever you square it to be. And again, you can plug that in or work it out step by step. All right, and that is lesson 35. All right, thank you so much for your time, and I hope you continue to enjoy your week.